Hello everyone, welcome to another edition of Sky Classroom Solution. Today I shall be looking at Cambridge 9709, Paper 5 Variance 2, May-June 2023. Now the first question is this. It's like a model. We are given a model. As you can see, the model is P. The model is for probability. You can see this is the model. So we are asked to draw up a table distribution. You have to draw up a table distribution. We are given the value of x to be minus 2, 2, 3. Now the value of x are minus 2, 2, 3. We have to put it in the table. Now this model, probability of x equal to k into bracket x squared minus 1. We are asked to use that model to find probability of x. Now, when x is minus 2, you put it there and find a probability. So when x is minus 2, that will be k into bracket minus 2 squared minus 1. So when x is minus 2, we have k, 4 minus 1. So that gives us 3k when x is minus 2. And the next one, when x is 2, that will be k, 2 squared minus 1. It also gives us 3k. The last one, when x is 3, that will be k, 3 squared minus 1. It gives us 8k. Now, all the probability, one of minus 2, 2, and 3, they're all in terms of k. But the question did not tell us to find the probability in terms of k. But the question said given the probability as a numerical fraction. So which means you are supposed to find the value of k. I'm very sure you are conversant with summation of all probabilities is always equal to 1. So 8k plus 3k plus 3k must be equal to 1. So we have 14k equal to 1. So in that case, k will give us 1 over 14. If k is 1 over 14, minus 2, probability of minus 2 give us 3k, and k is 1 over 14. Here will give us 3 over 14. This one is 3 over 14, and this one is 8 over 14. This is what they asked us to draw. The next one is you have to find expectation of x, that's mean. The formula is summation of x times probability of x, which means when you pick a value of x, you pick the respective probability. For example, now when I pick minus 2, its probability is 3 over 14. Multiply them together. Minus 2 times 3 over 14 minus 6 over 14. No, it's summation. Add. The next one is 2. It's also 2. This is 2. But probability is 3 over 14. Multiply them together. 6 over 14. The last one is 3. Its probability is 8 over 14. That's 24 over 14. So EX, when you find the LCM and do your addition and subtraction, you're going to have this. When you break it to the lowest term, you're going to have this. That's it. The next one is variance. This is giving your MF19. Variance is summation of x squared times probability of x minus expectation all squared. This is the formula for variance. So variance. So when you pick 1x, 1 over x is minus 2. You have to square it. When you square it, 4. So times its probability. Its probability is 3 over 14. 4 times 3 over 14, that's 12 over 14. The next x is also 2. 2 squared, 4. Its probability is 3 over 14. Also give us 12 over 14. The last one is 3. 3 squared, 9. 9 times 8 over 14, 72 over 14, minus our expectation. If you remember, that's the first thing we got, 12 over 7 all squared. So variance of x, 12 plus 12, 24, plus 72, I think it gives us 96. 24 plus 72, it gives 96. For the LCM is 14, 96 over 14 minus 144 over 49. So put this in your calculator. Let's see what we're going to get. So it gave us 192 over 49. Lowest term, or to decimal place, 3.92 to 3 significant figure. That's it. Let's see the next question. A sport event is taking place for 4 days, beginning on Sunday. It's going to take place on Sunday and going to take place for 4 days. So 4 days from Sunday, that will be Sunday, Monday, Tuesday, Wednesday. Now the probability that it will rain on Sunday alone, the probability that it's going to rain is 0.4. So what I'm going to do is that I will use black line for, let me do it like this, black line for rain, hold on, so to make my work easier, sorry, I'll use black line for rain, blue line, oh no, this is not blue, sorry, I need to be sure this is blue. Yep, I'll use blue line for not rain. Now this is Sunday. It rained on Sunday, probability is 0.4. It did not rain, probability is 1 minus 0.4, 0.6. Let me follow my rule, black line for rain. So it's stressful, but that's the best to do this. So you see the reason I'm doing this, it can be complicated with diagram. 0.4. Remember, black line is rain, blue line not rain. This is just for Sunday. The question now said, on any subsequent day, the probability that it will rain is 0.7 if it rained the previous day. It will rain if it rained the previous day. If it's black the previous day, probability that it will rain is 0.7, and 0.2 if it did not rain on previous day. Now, if it rain, let me first draw this complete. So to rain, not rain, rain, not rain. Yep. Now, as you can see, the tree diagram I sketched now is for 4 days. This is Sunday, this is Tuesday, this is Wednesday, Sunday, Monday, Tuesday, and Wednesday. Now there are 4 tree diagrams. Like it said, when you check the question, it's 4 tree faces because the event take place for 4 days starting from Sunday. You can see my label. I drew tree diagram for Sunday, for Monday, for Tuesday, for Wednesday. Now, the probability that it will rain on Sunday, only Sunday alone, the probability is 0.4. So probability that it will not rain automatically be 0.6, as you can see it. And the question now said, on any subsequent day, probability that it will rain is 0.7. Now, black line, black is for rain. Blue is for not rain. Not rain is blue. Black, if you see black line, that's rain. Instead of writing it out, but there's no space. I just use color to differentiate rain, not rain, rain, not rain, rain, not rain. But only on Sunday. Only on Sunday. Probability that it will rain only on Sunday is 0.4. It will not rain 0.6. On any subsequent day, probability that it will rain is 0.7 if it rained on the previous day, and 0.2 if it did not rain. On Monday, let's start from Monday. It rained on Sunday, so probability it will rain on Monday to be 0.7. So it will not rain to 0.3. Now, here on Sunday, the part that it did not rain, the blue part, since it did not rain, the part that did not rain, so if it's going to rain the following day, the question said 0.2 if it did not rain on the previous day. So here is 0.2, here is 0.8. Now let's fill this bit. On Tuesday, it rained on Monday, so probability that it rain on Tuesday will be 0.7. The other part, 1 minus 0, that will be 0.3. Now, the part that did not rain, so probability that it will rain now, 0.2, 0.8. Now, here is 0.2, it will rain here. So probability that it will rain the following day, that's 0.7, 0.3. It did not rain here. So probability that it will rain, the next is 0.2, here will be 0.8. Follow the process according to the instruction. Now, let's go back to Wednesday now. It rained on Tuesday, so probability that it will rain on Wednesday is 0.7. Here will be 0.3. It did not rain, probability that it will rain here, 0.2, here will be 0.8. It rained on Tuesday, so probability that it will rain on Wednesday will be 0.7, here is 0.3. It did not rain, here will be 0.2, here will be 0.8. It rained, here will be 0.7, here will be 0.3. It did not rain, here will be 0. This part that did not rain, it should be 0.2. Let me check it. So here will be 0.2, did not rain. Here is 0.8. It rained, 0.7, 0.3. Did not rain, 0.2, 0.8. Should be able to follow it like that. Now, let's solve the question. The first question, although it's 1 mark, but I drew that diagram to help to solve question B and question C. precisely. Diagram is for all the questions. You don't need to crack your brain with that diagram. After when you're now, don't forget black is for rain, blue line is for not rain. So I'm going to clean this side, but don't forget black is for rain. Black line it's rain, blue line not rain. Okay. Now the first question. Find the probability that it does not rain on any of the 4 days. It does not rain. Where you see black, 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 it does not rain. Okay. Where you see blue, blue continuously. This is black, black, black. It does not rain. Oh, I've seen it. Check this side. Blue. This is blue 1, blue 2, blue 3, blue 4. Probability that it does not rain on any of the 4 day is 0.6 times probability that it does not rain on any of the 4 days will be 0.6 times 0.8 times 0.8 times 0.8. The answer gives us 0.3072. That's it. The next question. Find the probability that on the first day which it rained. Find the probability that the first day on which it rained during the event is Tuesday. Find the probability that the first day on which it rained, the very first day it rained during the event is Tuesday. Let's go back. The very first day it rained during the event is Tuesday. The very first day. Let's check this on 0.6. Monday it rained. 0.6 here. On Sunday it does not rain. On Monday it does not rain. Then it rained on Tuesday. 0.2. 0.6, 0.8, 0.2. The very first day it rained. Okay, check it. The very first day on which it rained is Tuesday, which means it does not rain on Sunday. It does not rain on Monday. The very first day we see rain is on Tuesday. Now, look, it rained here. It does not rain at 0.6. If I check it up, it has rained on Monday. I don't need it. If I check it down, it does not rain. 0.8. Now, if I now check it up again on Tuesday, 0.2, it rained. So this is possible. So 0.6 times 0.8 times 0.2 times 0.7. You know, when you check it like this, 0. When you check it this, I mean this. .7. I think there's still one more possibility, or the very first day it rained is on Tuesday. Another possibility is this: 0.6, 0.8, 0.6, 0.8, 0.2. The very first day it rained. Yeah, it can also be 0.6 times 0.8. The very first day is Tuesday, this place, times 0.2. So it's not compulsory it rain the 4th day. If it rains, 0.7. If it does not rain, 0.3. The condition is that the very first day is on Tuesday. So where my target is, where the day it first rain must be on Tuesday, which means the previous day before Tuesday it cannot rain, but after Tuesday it can rain or not rain. No, it can rain and it also cannot rain. So I've considered that. So this is my possibility. So let's check it. 0.6 times 0.8 times 0.2 times 0.7. So we have 0.0672 plus 0.6 times 0.8 times 0.2 times 0.3. That gives 0.0288. Add it together. We have 0.096. If you have any question, you can put it in the comment section. I believe it's clear. Let's see the next one. Let me change my marker. The last one on this part. Find the probability that it rain. Find the probability that it rain on exactly one of the 4 days. Which means out of the 4 days, it can only rain once. Let's go back to our tree diagram where it rained once. Where it rained once. Where it rained once. Once. Which means that look for the place where just in between the 4 lines, you can only see one black line. In between, one black line. Oh, I've seen one. Look at this. 0.4 is only black. 0.3 is blue. 0.8 blue. 0.8 blue. You can see it. That will be the first possibility. 0.4 times 0.3 times 0.8 times 0.8. Only black line. Check it again. The one I use V for. 0.4, blue line, blue line, blue line. Let's see again where we can see one black line. Just one black line. Oh, I've seen another one. Let me be sure. This is blue line there. Blue line. Blue line. Blue line, blue line, black line, blue line, 0.6, 0.8, 0.8, no, 0.6, 0.8, 0.8, yeah, see this one, the one I put this dot, this is blue line. You are looking for just one black line. This is blue line, and this is black line. So 0.6, 0.8, 0.8, and 0.2. Another possibility, 0.6, 0.8, 0.8, and 0.2. Let's check if there's another possibility. 0.6, 0.8. Oh, see this one? Let me use another symbol. J is a blue line. Blue line. This is black line and blue line. So 0.6, 0.8, 0.2, and 0.3. Yeah. Another possibility. 0.6, 0.8, 0.2, and 0.3. Add. Let's see whether you can see another possibility. Blue, black, blue, blue, black, blue, blue. Oh, this one, 0.6, 0.2. Check where I'm saying it. 0.6, 0.2, down 0.3, down 0.8. The only one black line I can see there. You check it properly, you see it. So 0.6, 0.2, 0.3, and 0.8. So let's add it, multiply them, and add them together. 0.4 times 0.3 times 0.8 times 0.8. For the L, we have 0.0768. 0.6 times 0.8 times 0.8 times 0.2. So we have 0.0768. 0.0768, 0.8, 0.8, 0.2, 0.4 times 0.3 times 0.8 times 0.8, 0.0768, okay? 0.6 times 0.8 times 0.2 times 0.3. We have 0.0288. 0.6 times 0.2 times 0.3 times 0.8. We have 0.0288. Add them together, plus 0.0768 plus 0.0768. So everything gives us the total 0.2112. That's it. Next question. Okay. Now, the following back-to-back stem and leaf diagram represent the monthly salary in dollars of 27 employees of each of the two companies A and B. This is summation of the frequency. It's 27. We count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 for A and 27 for A and 27 for B. Summation of frequency. Look at the key. 1, 2, 7, 6. Like this. Sorry. The key is 1, 2, 7 means 2, 7 to the left means 2, 7, $10. 2, 7 to the right means 27, 6. That's 2760. So which means if I pick this 28 to the left, look at it here. You can see here 28 0 20 28 40 28 00 28 20 28 40. It's to the right. 28 00 28 10 28 20. Anyway, now the question asks us to find median and interquartile range. What's the formula for median? That's the first one. Median is summation of frequency plus 1. I added 1 to that summation because it is odd number. If it's even, there's no need to add 1. So the median will now be 27 plus 1 divided by 2. Don't forget the position. That gives me 14th position. Remember, I'm dealing with company A. What's the 14th position? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14th position. So it's 27, 1 to the left. It means 27, 1, 0 dollars. That's the median. They said interquartile range of this same company, IQ, interquartile range. It means upper quartile minus lower quartile. Upper quartile is 3/4 of summation of frequency. Remember, I added 1 because it's odd. lower quartile is 1/4 of summation of frequency. I added 1 because summation of frequency is odd number. So 3/4 of 28 minus 1/4 of 28. So this gives me 21, 21st position. This one is 7th position. So let's go to 21st minus 7th position. Now this is 14, 15, 16, 17, 18, 19, 20, 21st. And it's under 28.4. Remember that 28.4 means 2840. 7th position. My 7th position, sorry, should be 1, 2, 3, 4, 5, 6, 7. This is 7th position. That's 26.1. 26.1. That's 26.10. When you subtract them, we have $230. That's interquartile range. Now the next one is the graph. The lower quartile, the median, the upper quartile for the company B. Now we're talking about B at $2,600, $2,690, $2,780 respectively. Draw 2 box and whisker, 2 box and whisker plots in a single diagram to represent the information for the salary of the employee A and B. Now I'll use black for A. For A, the lowest is 250. As you can see, that's 2500, and the highest is 31. That's 3100. Let me label my. Okay, let me start from 2004. One box is so that is increasing by 100. There's 26. There's 27. There's 28. There's 29. There is 3000. And here is 31. Okay, and for box A, like I said, the lowest is 25. Let me put it here. The lowest for box A. So the outliers will be here, highest, the lowest, and the highest for box A. For company A, 31. That's 3010. That's 3010. And this is 1020. Yeah, each line is 10. So that will be here somewhere here. The highest for the outlier of company A will be somewhere here. Now, for company A, remember we got the lower quartile to be 2610. Lower quartile is 2610. 2610. Lower quartile is 2610. So that will be some lower quartile over here, 2610. And upper quartile is 28 something. 2840. 2840. 10, 20, 30, 40. 2840 should be here. So just join them together. Just once you get the line, this is the key. So join them, the outlier. So this side is Q1. 1, 2, 3, 4. I didn't put it here anyway. So this side, let me take it up. Q1. This side Q2. But this is the outlier. So this company A up. Now company B. Company B. Now the same thing. What are the outliers for company B? Let me look for the lowest first. The lowest for company B is 2.4. That's 2.540. 2.540. 2.540. 10. Somewhere here. 10, 20, 30, 40. The highest for company B. The highest for company B is 3090. 3090. That'll be somewhere here. Now, Q1 for company B. I think they've given that from the question. Lower quartile is 2.6. Lower quartile is 2.6. Upper quartile, sorry, median 2.690. Median 2.690. Oh yeah, I didn't consider median the first one there. These are median. And upper quartile 2.780. Upper quartile 2.780. 2 line before 2.8. Yeah. So this is it. This is what they want us to draw. Yep. Join the outlier. Don't mix the line. If you have time to label Q1, look at the line. Q2, look at the line. Q3. This is what they want us to do. Now, what the median for company A? I forgot to put that. Company A, the median is 2.710. 2.710. It's somewhere here. Look at the line. It's Q2. Here's Q3. That's it. So the one down is company B. Let's move to the next question. Comment on whether the mean would be more appropriate measure than median for comparing the given information. Okay, we are asked to comment whether mean will be more appropriate measure than median for comparing the given information. Now, I noticed something. When you check company B, in company B, after 2.820, which is this one, the next one is 3090. Company A, after 2990, the next one is 3010. Now, it's still close, but there's a discrepancy between the second to the highest and the highest. The difference is a bit wide. So if you have to use mean, in this situation for company B, it's not going to give us something reasonable, because mean or average is supposed to give us something close to each other. That's supposed to be, the value are supposed to be close to the value inside this company. compared to company A, they are very close to each other. We have a reasonable value if you use mean. But if you use mean in company B, a bit odd because the highest and other values, the difference is too much compared to company A. So what I will suggest is this. Median, median would be more appropriate. Median will be more appropriate because there is an anomalous value, a value that is inconsistent, anomalous value of $30.90 for company A, in company A, which would affect the mean. This is what I think. Do your research, you get to know that the mean will not be appropriate because of gap in values. So median will be appropriate in that case. Number 4. We have a five-sided spinner, label 1, 2, 3, 4, 5. The spinner is spun repeatedly until a true is obtained. So a probability of a 2 in this case, 2 can only occur once here. Out of 5 is 1/5. Probability of not 2 will be 4/5. Okay. The random variable x denotes the number of spin required. The number of spin required. Find the probability of x equal to 4. X equal to 4 means that the spinner was spun 4 times, which means that a 2 appear on the 4th throw, which means the first throw they miss it, they miss the second throw. That's why they keep repeating it until they get a 2. Third one, the 4th one, they now get a 2 on the 4th time. So between the first 3, they didn't get a 2. A probability of not a 2 is 4/5, and they did it 3 times, raised to power 3. On the 4th throw, they got a 2, which is 1/5. Use your calculator. We have 0.1024. That's it. The next question. So probability of x less than 6. It simply means that up to the 5th time they do not fail. That's the meaning. It means 1 minus up to the 5th time they do not fail. Negation of failing. That's the term anyway. So the general form is if you have probability of x less than r, it means 1 minus q raised to power r minus 1. That's the general form. Probability of x less than 6 is 1 minus 4/5 raised to power 5, which gives us 0.67232. That's it. Now the last part no, not the last part. We have 2 more questions on this part. Okay, the next part is this, the 3 marks question. 2 fair 5-sided spinner. Label 1, 2, 3, 4, 5. 2. 1, 2, 3, 4, 5. There are 2. 1, 2, 3, 4, 5. They are spun at the same time. The number are equal. The score is 0. If the number are equal, the score is 0. And if the number, otherwise the score is the higher number minus the lower number. Okay, this is 1 1, the score will be 0. 1 2, the higher minus lower 1. 1 3, higher minus lower 2. 1 4, 4 minus 1 3. 1 5, 5 minus 1, that's 4. Okay, let me separate them from the result. Okay, 2 1, the difference and higher and the lower, that's 1. 2 2, they are the same, the score is 0. Here will be 3 minus 2 1, 4 minus 2 2, 5 minus 2, this is 3. 3 1 2, 3 2 1, 3 3 0, 3 4 1, and 3 5, that's 2. 4 1 3, 4 2 2, 4 3 1, 4 4 0, 4 5 1, 5 1 4, 5 2 3, 5 3 2, 5 4 1, 5 5 0. That's it. This is the outcome. So the question asks us to find probability that the score is greater than 0, given that the score is not equal to 2. This is it. This is Bayes' theorem. Probability that the score is greater than 0, given that the score is not equal to 2. That's what they ask us. So that will be probability that the score is greater than 0, given that it's not equal to 2. Now let me put it like this. So we have to find probability of the score is greater than 0, as you can see, given that it's not equal to 2. Let me put this one as, let me represent the event as B and this one as A. It's called conditional probability. Probability of B given A. It means probability of A intersection B all over probability of A. So probability of B given A. So now we are going to follow that pattern. Now, which means if I'm going to follow that pattern, it means probability of x greater than 0 intersection s is not equal to 2 all over probability of x is not equal to 2. That's the same thing I did for conditional probability now. So from here, what is probability of x greater than 0 given that it's not equal to 2? So in that case, we have x greater than 0 given that it's not equal to 2. Let me check it. S greater than 0 and is not equal to 2. Let's count it. It's greater than 0 but not equal to 2. 1, 2, 3. Is not equal to 2 but greater than 0. Okay, 1, 2, 3. 1, 2, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 10, 10, 10, 10. Okay, I've seen 10, 11, 12, 13. Oh yeah, 14. 1 is inclusive. It's greater than 0 but not equal to. greater than 0 but not equal to 2. You just omit only 2. Anyone greater than 0 but not equal to 2. They are all 14 in number, and the total sample here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 25. So probability that x is greater than 0 but not equal to 2 is 14 over 25 divided by probability of x not equal to 2. The ones that are not equal to 2. Not equal to 2. Let me change my pen to do that one. So not equal to 2, we have 1, not equal to 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Not equal to 2, they are 19. Not equal to 2, they are 19. So all over 19 over 25. At the end of the day, so what do we have? This out. We have 14 over 19. So 14 divided by 19. 0.737. That's it. Let's move to the next one. And the next one is two spinner are spun at the same time repeatedly. Two spinner are spun at the same time repeatedly. Now, the two spinner are spun at the same time repeatedly. Two spinner, that the previous two spinner, that's what they're referring to. Now they spun them at the same time repeatedly for 9 randomly choosing spins of two spinner. The number of times it was spun, it was 9. Find the probability that the score is greater than 2. Let me start with that statement. Probability that the score is greater than 2. Let's go and check it. Probability that the score is greater than 2. Let me use another color for that. Greater than 2. 1, 2. No. This one are not part of it. Start from here. 1, 2. Greater than 2. 3, 4, 5, 6. Probability that the score is greater than 2 is 6 out of 25. Let me go back to my black. On at least 3 occasions. On at least 3 occasions. At least is greater than or equal to 3, which would be 1 minus probability of x less than 3. That's the meaning. That will be 1 minus, you're going to do x0, x1, and x2. So in this case, it's binomial. It's been binomially distributed. Do you know why? Because I have number of trial 6 and probability of success 6 over 25. So, and the formula is probability of x equal to r. The formula is n combination r, p raised to power r, q raised to power n minus r. So we are dealing with 0, 1, 2. That's 1 minus, when it's 0, n is 9. 9 combination 0. Success is 6 over 25 raised to power 0. Failure is 1 minus 6 over 25. That's 19 over 25 raised to power n minus r. 9 minus 0, 9. Plus, when is 1, that's 9 combination 1, 6 over 25 raised to the power 1, 19 over 25 raised to the power 8. The sum must give us 9, sum of power, plus 9 combination 2, 6 over 25 raised to the power 2, 19 over 25 raised to the power 7. So do your maths. Then we have the answer give us, we have 1 minus all this one in the bracket gives 0.6287. So then we have 0.3713. That's the answer. Believe we got it right. Now, number 5. The length of western bluebird are normally distributed with mean 16.5. The mean is 16.5. This is the mean, 16.5. Standard deviation. The standard deviation is 0.6 centimeter. A random sample of 150. This is n. Random sample of 150 is selected. How many of these 150 would you expect to have a length in between? In between means probability of 15.4 less 15.4 less than x less than 16.8. Now, this distribution is normally distributed, so which means that x is normally distributed. You're going to have something like this. The mean is 16.5 and the variance is 0.6 squared. This is how you're going to represent it. So standardize it using z equal x minus mean over square root of variance. That's standard deviation. So probability of 15.4 less than x less than 16.8. 16.4, if less than x less than 16.5. When you standardize it, it becomes 15.4 minus mean, which is 16.5, divided by square root of the variance. Square root of variance 0.6 square, sorry. Square root of variance will give us 0. So square root of variance will give us 0.6. Less than z. I've standardized it less than 16.8 minus 16.5 all over 0.6. At the end of the day, we have probability of, when you do your maths, 15.4 minus 16.5 divided by 0.6 will give us minus 1.833 less than z. The other one, 16.8 minus 16.5 divided by 0.6, that gives us 0.5. It's like, this means, it means this relation, this model means phi of 0.5 minus phi of 1 minus 1.833. When you check your distribution table, so we have, okay, let me do it one by one. Phi of 0.5 minus phi of negative usually 1 minus phi, 1 minus phi of 1.833. So at the end of the day, we have phi of 0.5 minus 1 plus phi of 1.833. So when you check your table, phi of 0.5, you're going to give us 0.6915 minus 1 plus 1.8 under 3 and add the other one. So you're going to give us something like this. Going to give us 0, let me check it properly. So 1.8 under 3 gives 0.9664 plus 1.8 under 3, then trace it out another 3 again, under 3, okay, 2, that's plus 0.0002. So we have 0.9666. At the end of the day, when you add them together minus 1, we have 0.6581. But the question asks us to find how many of these 150 bed will you find. So the probability is 0.6581 multiplied by 150. So we have 0.6581. So we have 98.72, which is 99 boards. That's it. Next question. The length of eastern bluebird are normally distributed with a mean is normally distributed with a mean of 18.4 and standard deviation of this, as variance of this. It is known that 72% of eastern bluebird have a length 72% have a length greater than 17.1. So probability of x greater than 17.1 is 72%, that's 0.72. So let's standardize this. So when you standardize this, that will be z greater than 17.1 minus the mean 18.4 over square root of the variance, give us standard deviation. It gives us 0.72. So from here, probability of z, when you subtract this, we have minus 1.3 over this equal 0.72. So again, so z greater than minus 1.3 over standard deviation. So it means that since it's greater than, you have to apply this rule. If you have probability of z greater than minus a, it means phi of a, that's the meaning. So probability of z greater than minus 1.3 over standard deviation means phi of 1.3. Go back to your rules, you see all this equals to 0.72. At the end of the day, we have 13 over this equal inverse of 0.72. Not 13, sorry, 1.3 over this. Let's check the inverse of 0.72 in the table. So 0.72, 0.777, 0.72. Okay, it's closer to 0.5 under 83. Yeah, 0.72 we have 0.583. Cross multiply, we have 1.3 equal to 0.583 standard deviation. So hence standard deviation is 1.3 divided by 0.583. So your sigma, your standard deviation, is equal to 2.23. That's it. Let's move to the next one. Question C. A random sample of 120 eastern bluebird is chosen. A random sample of 120 eastern bluebird is chosen. Use an approximation to find the probability that fewer than 80 of these 120 birds have length greater than 17.1. Don't forget the previous question. Probability of x greater than 17.1 in the previous question was 0.72. So in this case, probability of success in this case is 0.72 because the bone of contention here is greater than 17.1. So P is 0.72. So Q 1 minus 0.72, we have 0.28. That one is settled. And they said the random sample of 120 eastern bluebird, N is 120. Use an approximation to find probability that fewer than 80, that's x less than 80. Use an approximation. Now, let me give you some rules about this approximation. So the rules are as follow. Just a gentle. So the rules are: if its probability of x greater than a, what you do that it will be probability of x greater than, you add 0.5 to a. If it's less than a, what you do is that if it's less than a, you subtract 0.5 from that a. If it's less than or equal to a, you're going to add 0.5. If it's greater than or equal to a, you're going to subtract 0.5. You should get used to this. Okay, my students are well familiar with these rules anyway. So standardize, since you're applying continuity, they say use approximation. So whenever I see the word approximation, this is the continuity they want you to do. Let's standardize probability of x less than 80. When you standardize it, that's z less than, less than 80, subtract 0.5, 79.5 minus our mean. So we are not given mean. Remember that mean is NP and N is 120. Probability of success is 0.72. So our mean is 86.4. Variance in this case is NPQ. That's 120 times 0.72 times 0.28. So variance in this case is 4.9185. So 86.4 divided by square root of variance, square root of 4.1985. So we have probability of z less than minus 1.403. So which means is 1 minus phi of 1.403. Phi of 1.403, which means use your table, you need to give you 0.9192, which gives 0.0804. That's it. I believe you understand. Any question should be welcome on the comment section. Okay, which means the distribution can be written like this. No, it's normally distributed. If you convert it to normal, at the end of the day, the mean 86.4, this variance there's a variance 4.9185. That's a variance. So we can write it like this: 2.218 squared. Now let's see the last question, number 6. I think this is the last question. Okay. In a group of 25 people, there are 6 swimmers. We have 6 swimmers, 8 cyclists, 11 runners. Okay. Each person competes in only one of these sports. A team of 7 is selected. You want to select a team of 7 from these groups to take part in the competition. Find the number of different ways in which the team of 7 can be selected if it consists exactly one swimmer. A team of 7 is to be selected. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It must contain one swimmer is fixed, and the one swimmer should be from these 6. That's 6 combination 1, and at least 4 cyclists. 4 cyclists. There must be at least 4 cyclists. The minimum of cyclists, the one there is 4. 4 cyclists, and the cyclists must be from 8 combination 4. The total is 4, and 2 runners. Just 2 runners. They must be from the total. Now, it must be just 2 runners and 1 swimmer, but at least 4 cyclists. We've taken 4. So it could be this also. It could be this again. 6 combination 1 does not change. So we can increase the cyclists to 5 now. Once I increase them to 5 out of 8, then it remains 1 runner. 11 combination 1. This is what I did. Still 1, 2, 3, 4, 5, 6, 7. One swimmer is fixed. Now I've already picked 4 cyclists. Since they mentioned at least 4 cyclists, so we could still get 5. 1, 2, 3, 4, 5. So they said at most 1 runner, at most 2 runner. So the 2 runner can be 1. It can at most means 2 or less than. So that's what brings about this. Nothing will change from the swimmer is still 1. It must contain exactly 1 swimmer, nothing changed. Now I can increase the cyclist. I can increase the cyclist to 6 because they said at least 4. Once I increase the cyclist to 6, making 7, so there will be no runner anymore. There will be no runner. So this is what they want to pick. So at most 2 runner means 2 or less than 2. At the end of the day, so this is what I did here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There must be exactly 1 swimmer. Since I've increased the cyclist to 6, so there's no space for the runner. So the total combination will be add the first, second, and the top one. 6 combination 1 times 8 combination 4 times 11 combination 2 plus 6 combination 1 times 8 combination 5 times 11 combination 1 plus 6 combination 1 times 8 combination 6. So when you do this together, okay, oh, that's it. Don't let us forget this since, okay, there's something I omitted. What's the factor then? Don't let us forget that since there's no room for swimmer in the last part, so it can be 11 combination 0 because at most 2 means 2, 1, and 0. That's meaning of at most 2, 1, and 0. At the end of the day, when you add them together, let's do our simple addition. So when you add them together, so this one will most likely give us 2, 3, 100. This one will give us 3, 6, 9, 6. While this will give us 168. When you add them together, we have 26, 9, 6, 4. That's the number of ways this arrangement is possible. Now B part. Now for another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. How many the team members stand in the line for a photograph? Okay. How many different arrangements are there of the 9 people if the swimmers stand together, the cyclists stand together, and the runners stand together? A team of 9 people consists of this. How many different arrangements are there when they stand together? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Swimmer will stand together. Cyclists stand together. Cyclists are how many? 3. Runners stand together. When these swimmers stand together, that's 2 factorial in arranging them. When these people stand together in arranging them, it can be arranged in 3 different ways, 3 factorial. These people can be arranged in 4 different ways, 4 factorial. So the number of arrangements is 2 factorial times 3 factorial times 4 factorial. We have 1728 ways. That's it. The last part, question C. Question C is how many different arrangements are there of the 9 people if none of the cyclists stand next to each other? None of the cyclists stand next to each other. None of the cyclists. How many cyclists do we have? We have 3 cyclists. So when you take away the 3 cyclists. 1, 2, 3, 4, 5. The 1, 2, we have 7 space. Let's see it first. The cyclists are 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see it like this. So when you take away the cyclists out, we have 6 space. 1, 2, 3, 4, 5, 6. The total is 9. I've taken away the cyclists. Do you know why? Because the question said the cyclist, the streamers stand together. No, sorry. The question says if none of the cyclists stand next to each other. None of the cyclists. We have 2 swimmers, 3 cyclists, and 4 runners. 2 swimmers, 3 cyclists, and 4 runners. So 1, 2, 3, 4, 5, 6. I've taken away the cyclists. Now, and which means these 6 spaces can be filled up by the swimmer and the runner. Swimmer, swimmer, runner, runner, runner. They can be arranged anyhow on this space. That's 6 factorial. But the cyclists cannot be together. So the cycle can be here, it can be here, it can be here, here, it can be in between. So the cyclists, they have how many spaces to fill up? 1, 2, 3, 4, 5, 6, 7. And we have how many cyclists? 3. That's 7 permutation 3. Or let's look at it in this way. 6 factorial times 7 permutation 3. We have 151, 200 ways. That's the answer. Or look at it in this way. I've taken away the cyclist, right? Okay. This is swimmer, swimmer, runner, 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 runner. They can be like this. So now we have this space left for the cyclist. 1, 2, 3, 4, 5, 6, 7. So if one of the cyclists filling this space, it has 7 options. It has 7 options of filling this space. 7 options. Now, the remaining 2 cyclists have 6 options. It means, and the last one, if you pick any of them, it reduces to 5. So the last cyclist has 5 different ways in doing it. So at the end of the day, so we have, and there are 3. Okay, hold on. Let's put it like this. Let's see like this. Like this. I think the first method, I think it's simple. It's not complex. Let me stick to the first method. As you can see, how many different arrangements are there of the 9 people if none of the cyclists stand next to each other? I've drawn it. None of the cyclists can stand next to each other, which means the swimmer and the runner can be next to each other in 6 ways, 6 factorial. So the cyclist has these 7 spaces to fill, and there are 3. So 3 people to fill in 7 different spaces. That's 7 permutation 3. So we have this. That's the answer. Thank you. Please subscribe to my channel. More content, more interesting content are dropping almost every day now. So subscribe, share. Thank you.